Hi children, hello, welcome to your home school. This year class 10 mathematics NCERT or CBSE board. We are in our chapter 8 real numbers and we need to start today exercise 8.3. Before starting this exercise, we are going to deal with a small theorem. Theorem 8.3. Let P be a prime number if P divides A square, then P divides A where A is a positive integer. Have to remember this statement easily, children. Let P be any prime number. If P divides A square, then P divides A where A is a positive integer. Have to remember this statement. Let P be a prime number. If P divides A square, then P divides A where A is a positive integer. How can we prove this? Let us start our proof. Let P be a prime number. What is this P denominator, children? Any prime number. Let P be any prime number. The prime factorization of A be as follows. We are talking about the positive integer. Let A be the positive integer, P be the prime number. And what are the factors of A, children? Let A is equal to P1, P2, P3, so on up to Pn. What are all these? Factors of a positive integer. Let A be a positive integer and these are all the factors. P1, P2, P3, so on up to Pn are all the factors where P1, P2, P3, so on up to Pn are primes and they are not necessarily distinct. Means same numbers they may be. Let us do squaring on both sides. A square. A square, how can you write? A into A can we write? Similarly, let me write here. P1, P2, P3, so on up to Pn into P1, P2, P3, so on up to Pn. These are all the factors. Right? A square can be written as A into A. Now multiply this, what happens? P1 square into P2 square into P3 square, so on up to Pn square. What is the given statement? It is given that P divides A square. So before dealing these four lines, I want to give you an example. A. What is A? Positive integer. Let me take A is equal to 10. So, what I am going to take here? Let P be the prime number. I take what are the factors for A, children? See this step. What are the factors for A? 10 can be written as 2 into 5. Right? 2.5, 2 into 5, 2 comma 5. These two are the factors. Next, square. A square means what? A square is equal to 10 tens are 100. A square is 100. What is the given statement? Given that P divides A square. What is P? Let me take any one prime number. Let me take 2. It is given that P divides A square. P divides A square. Is it dividing? Yes, it is dividing. That means they have given a statement P divides A square. Now, when it is able to divide, when this is a factor, A square or A, you have this. When the prime number is able to divide, that prime number should be a factor of this. When it is a factor, then only it can be divided. Observe here, children, carefully. Where A is equal to 10. A square 10 into 10. Right? If A square is divided by some prime number, if it is able to divide, is it able to divide A? Let's check it out. What is A? 10 by 2. Yes, definitely it is going to divide. Why? It is also a factor. A square is just double the numbers. A is single time written here. A square is double the numbers. If any prime number is able to divide the A square, then it is definitely going to divide A. So once again have a look here. I hope this example is clear for you. If A square is divided by P, then it is divided by A also. Let A be the factors. What are the prime factors here? P1, P2, P3, P, so on up to Pn. What we have done? A square multiply double times A into A. Then A square is nothing but P1 into P1, P1 square, P2 into P2, P2 square, P3 into P3, P3 square, so on up to Pn square. It is given that P divides A square. What is the statement given? They have given this. We need to prove this. From fundamental theorem, what is the fundamental theorem, children? If it is dividing A square, when it divides, then P must be a factor of A square. We have seen in our fundamental theorem. Similarly, it follows that P is one of the prime factor of A square. Prime factors of A square are P1, P2, so on up to Pn. So, P is one of among this P1, P2, P3, so on up to Pn. Therefore, I write it as A is equal to P1, P2, so on up to Pn, where P divides A. So, final statement, what we can say, children? If P is a prime number, if P divides A square, then P divides A, and A is a positive integer. When it is able to divide A square, then it definitely divides A. That's it. Let's start our exercise 8.3. Your first problem is prove that root 5 is irrational. So, what is a rational number, children? The number which can be expressed in the form of P by Q, where P and Q are co-primes and Q cannot be equal to 0. We know this statement. But what is irrational? The numbers which cannot be expressed in the form of P by Q are called as irrational numbers. By seeing this, root 5, directly I say that it is an irrational number. But we need to prove. How can I prove this? Let us assume it's contradictory. Opposite, what is that? It is an irrational, we know. But let me assume it as a rational number. Let us assume it as a rational number. If it is a rational, what we can say? It can be expressed in the form of P by Q. And they are co-primes. Co-primes means what, children? Suppose let me take here 2 and 5. I say that those two are co-primes. Why I am saying co-primes? See here, what are the factors of 2? 2 into 1. And what are the factors of 5? 5 into 1. Means they doesn't have any common factor other than 1. Or you can say there is no common factor for the two numbers. So these two we call it as a co-primes. What are these, children? Co-primes. So if we take it as a rational number, then 2 by 5, I say that they are co-primes and it is a rational number. They are not having other than 1 as a factor. Common factor is not there. So it is a rational number. Suppose let us assume this as a rational number and let us see if they have only 1 as a common factor. We say that it is a rational number. Otherwise, it is an irrational number. What are co-primes? The numbers which does not have any common factor other than 1. Let us start our problem here. How can we start? Let us assume root 5 as a rational number. Root 5 as a rational number. If it is a rational number, what can we write here? Root 5 must be equal to, you may take P by Q, you may take A by B, any value you can take. Let me take here A by B. I write here where A and B are co-primes, I am saying. Co-primes and B cannot be equal to 0. When I assume it as a rational number, then that must be equal to A by B. If A by B, if I say A and B are co-primes and B cannot be equal to 0. Now next step, squaring on both sides. Root 5 whole square is equal to A by B whole square. Square root cancels, children. 5 is equal to A square by B square. Send this B square this side. 5B square is equal to A square. Okay. Now, look here carefully. This 5, if it comes this side, what happens? This is a multiple, right? If it comes this side, it can divide. Then what I can say? According to the theorem, I say that 5 divides A square, then automatically 5 divides A. Okay? Now, let us assume, let me take here A is equal to 5. Any letter, any integer you can take, either C or M or K, anything you can take. Let me take here A is equal to 5C. Substitute this 5C in A, please. Substitute, children. Substitute A is equal to 5C in equation 1. If you want, you can take A equal to 5C in equation 1. That will be 5B square is equal to 5C whole square. Remove from brackets. 5 5s are 25C square. Okay. Now cancel 5 1s are 5 5s are. Then what happened here? B square is equal to 5C square. Again observe here, children, this 5 multiple. If it comes this side, it will be divided. Therefore, what I can say? Therefore, 5 divides B square by theorem. If it is dividing B square, 5 divides B. So, finally, what we can say, children? Therefore, A and B have 5 as a common factor. A and B have 5 as a common factor. If it is having a common factor 5 other than 1, then does it become a co-prime? No, it does not become a co-prime. So what we have assumed is wrong. Therefore, this is contradictory to our assumption that there is no common factor for A and B. Therefore, what happens, children? This is a contradictory to our assumption that there is no common factor for A and B. Therefore, final answer you can say that hence root 5 is an irrational number. Therefore, root 5 is an irrational number. So, once again observe here carefully, children. What we need to prove? Root 5 is an irrational. We know actually it is an irrational. But how can I prove? I have assumed it as a rational number. Right? If it is a rational number, it should be equal to P by Q or A by B. Any rational number you can take. Where, what is the condition? If it is a rational number, what I can say? A and B must be co-primes. Co-primes means it does not have any other common factor other than 1. If it have a common factor, it is not a rational number. So, according to this line, we are trying to prove this one. And B cannot be equal to 0. How did we start our proof? Root 5 is equal to A by B. Squaring on both sides. Root 5 whole square is equal to a by b whole square. Square root cancel, 5 is equal to a square by b square. Send this b square this side. 5b square is equal to a square. 5 divides a square. 5 divides a. According to the theorem, I said that this 5 divides a square and it also divides 5 divides a. Let a is equal to, I have assumed a is equal to some other 5 and some other integer. 5c I have taken. Substitute a equal to 5c in equation 1. 5b square is equal to 5c whole square. 5 and 25 cancels here. B square is equal to 5c square. Now I can observe 5 can divide b square. Therefore, according to the theorem, I can say that 5 divides b square. 5 divides b. Therefore, the 5 is a common factor which is dividing a and b. Therefore, a and b have 5 as a common factor. This is a contradictory to our assumption that there is no common factor for a and b. Therefore, hence root 5 is an irrational number. So look here children, I am going to explain you whatever question asked in your exam you will be able to answer. We have done in our exercise only root 5. Same thing, you may take root 2, root 3, root 7, root 10, like this, any number asked, you may prove same manner. There is no change. So let us prove here. What shall we take here? Root 3 children. Prove that root 3 is irrational. How can we prove this? Let us assume root 3 as a rational number. If it is a rational number, it should be equated to a by b, where a and b are co-primes or integers you can say, and they does not have a common factor other than 1, and b is not equal to 0. Squaring on both sides, root 3 whole square is equal to a square by b square, and root and square and root will be cancelled. 3 is equal to a square by b square. Send this b square this side. 3b square is equal to a square. Same steps children, there is no change. Next line, what I can say, 3 divides a square. Therefore, 3 divides a. Let us assume a is equal to what number you have? You have to take that number here. Let a is equal to 3c. Substitute a is equal to 3c in equation 1. Substitute here 3b square is equal to 3c whole square. 3 3s are 9c square. Cancel 3 3s are 9. B square is equal to 3c square. Now what I can say, 3 divides b square. 3 divides b. Means a and b have 3 as a common factor. This is contradictory to our assumption that there is no common factor for a and b. There is no common factor we have said now. But there is a common factor here. What is that? 3. Other than 1, we have another common factor. If we have a common factor, we say that it is a irrational number. Right? It is not a rational number. Therefore, it is a irrational number. Our assumption is wrong. Therefore, hence, root 3 is an irrational number. Similarly, no change children. Suppose if they ask you 7, same manner, root 7, change wherever you have 3, just go with 7. Look here how I am changing. 7b square is equal to a square. 7 divides a square. 7 divides a. When you have this, you take here 7c. Same manner, 7, 7, 7 you change. Then what you are going to get here? 7 as a common factor. 7 divides b square, 7 divides b. Therefore, a and b has 7 as a common factor. Therefore, according to our contradictory, our assumption is wrong and it is having a common factor. Therefore, it is not a rational number. It is a irrational number. See the second problem. Prove that 3 plus 2 root 5 is irrational. Same process children, but when we have a single surd, it is different and this will be little different. So have a look here. How can we solve this? Let us assume 3 plus 2 root 5 is a rational number, or a rational, you can say, rational number you can say. If it is a rational, what I can say, it must be in the form of P by Q form. P by Q you can take, or A by B, anyone you are comfortable. Let us assume it as a rational. If it is rational, I am going to equate it with A by B. Okay. So now what is the thing we need to do? Solve the equation such that only surd should be on one side, remaining all other side. Look here carefully. This 3 send other side. 2 root 5 is equal to A by B minus 3. 2 root 5 is equal to, do LCM, A minus 3B by B. And now this 2 multiples send this side, it will be divided. A minus 3B by 2B. So when we assume it as E by B, you can write that where A and B are co-primes, and B cannot be equal to 0. Right? What we have done? Plus 3 send this side, minus 3 do LCM. Right? This 2 multiples send other side, it will be divided. Finally, what you can say? This is in the form of a rational number. But this equal to this cannot become a rational number. Since A and B are integers, therefore A minus 3B by 2B is a rational number. But root 5 is an irrational number. Therefore, this shows that our assumption is wrong. Therefore, what I can say? 3 plus root 5 is a irrational number. Finally, we proved that it is a rational number only. So once again, have a look, children. When you have these type of problems, how to prove this? Prove that 3 plus 2 root 5 is irrational. We know that it is an irrational, but we need to prove, right? So let me assume it as a rational. If I assume it as a rational, it should be equal to A by B, where A and B are co-primes and B cannot be equal to 0. So what we need to do? We need to convert this in such a way only surd form should be in the LHS side. That is 2 root 5 is equal to A by B minus 3. Do LCM. A minus 3B by B. Root 5 is equal to A minus 3B by 2B. So finally what I can say? This is a rational. This set is a rational, but this cannot be a rational. Therefore, complete is a irrational number. Since A and B are integers, A minus 3B by 2B is a rational number, but root 5 is an irrational number. This shows that our assumption is wrong. What we have assumed as a rational is wrong. Therefore, 3 plus 2 root 5 is a irrational number. Similarly, I am going to give you one more example here, children. Suppose, let us take 2 minus 3 root 5. See here, most of the people will do mistake in these type of problem. Same method, there is no change. Let us assume 2 minus 3 root 5 is a rational. Okay. So let us assume it is a rational. If it is a rational, we must equate it with A by B or P by Q. And A, B are co-primes where B is not equal to 0. Same statements you write. Now this conversion you do mistake, children. when you have a negative here, so what you do, better you send this that side and this side. So look here carefully, 2 minus a by b is equal to 3 root 5. Most of the people will write minus 3 root 5 is equal to a by b minus 2 here, minus they leave as it is and do mistakes in exam. When you have a negative, better try to send this part to other side. Now 2b minus a by b is equal to 3 root 5. Finally, I may write it as 2b minus a by 3b. At a time reverse. 2b minus a by 3b is a rational number and root 5 is not a rational number, it is an irrational number. Therefore, finally I can say that 2 minus 3 root 5 is a irrational number. As my assumption is wrong, it becomes a irrational number. So, one more type you have, children. One more type of problem you can see in your exam similarly. Let me take one more problem. Root 2 minus root 3. Prove root 2 minus root 3 as an irrational. How can I prove this type of problem? As in your textbook, only one problem there. But you may have a chance of asking these also. Prove root 2 plus I'll take first. Root 2 plus root 3 is irrational. What is this? By seeing itself, it is irrational. But we need to prove, right? So, let us assume it as a rational. Rational means it should be equal to a by b, where b cannot be equal to 0. Now, further what I need to do? Squaring on both sides. We need to try to remove the root. Root 2 plus root 3 whole square is equal to a by b whole square. Now, what you can see here? A plus b whole square formula, right? Apply here. That becomes root 2 whole square plus root 3 whole square plus 2 into root 2 into root 3 is equal to a square by b square. Now square root will be cancelled. 2 plus 3 will be 5. 5 plus 2 root 6. Single root, your order is same, you can multiply. Now this one, how can you write this one, children? 5 plus 2 root 6 is equal to a square by b square. 5 send other side. 5 send other side, it will be subtracted. 2 root 6 is equal to a square minus 5b square by b square. Your final answer will be a square minus 5b square by 2b square. Therefore, this becomes irrational and this becomes irrational. Therefore, my contradiction is wrong. My assumption is wrong. And I can say that root 2 plus root 3 is irrational. It is irrational. Once again, understand here carefully, children. When you have a negative sign, try to take negative term other side and prove that it is irrational. Suppose if you have like this root 2 plus root 3 or root 2 minus root 3 you have, don't be panic. Just equate with the rational number, that is a by b, and square on both sides, apply the identity. So finally 5 plus 2 root 6 is equal to a square by b square. So this step is similar to this, no? Then there onwards, same manner. 5 send other side, do LCM, then this becomes irrational, this cannot be rational, this is irrational. Therefore, my assumption is wrong. According to this, I say that root 2 plus root 3 is a irrational number. See, third main, children, prove that the following are irrational and we have 3 sub-questions. What are those? 1 by root 2, 7 root 5, 6 plus root 2. Same manner, we need to prove them as a irrational. Let us start here. 1 by root 2. Let us assume 1 by root 2 as a rational number. Rational number means what, children? It must be in the form of p by q. So, if you want, you can take here p by q. P by q or a by b, anything you can take. where P and Q are integers you can write, are co-primes you can write. Integers and Q cannot be equal to 0. Now, what I need to do now? So, send this side. What happens? Q by P is equal to root 2. At a time, do reverse. Where P and Q are integers. Therefore, I see that Q by P is a rational number and this is an irrational number. Therefore, my assumption is wrong. I say that 1 by root 2 is an irrational number. That's it. Very simple. Therefore, P and Q are integers. That means Q by P is a rational. Q by P is a rational number, but root 2 is irrational. Therefore, our assumption is wrong. What assumption? As irrational, it is wrong. But what I can say? Our assumption is wrong. Therefore, 1 by root 2 is a irrational. Therefore, 1 by root 2 is a irrational number. This is the thing we need to prove. Okay. Same manner, children. 7 root 5. What we need to do? Let us assume 7 root 5 as a rational number. If it is irrational, it should be equated to P by Q. 7 root 5 is equal to P by Q. Same statement where P and Q are co-primes and Q not equal to 0. You can write the same statement here, children. Now, other than root 5, what there extra? Send that value this side. Root 5 is equal to P by 7Q, where P and Q are integers. Therefore, 7 by PQ is a rational number. But what I can say, children, root 5 is a irrational. This is rational and root 5 is a irrational number. Therefore, my assumption is wrong. I can say that 7 root 5 is a irrational number. Finally, I say it is a irrational number. Right? Similarly, prove the third one, children. 6 plus root 2. What is your first step? Let us assume it as a, let us assume 6 plus root 2 as a rational number. If it is irrational, we can equate to P by Q form. That is 6 plus root 2 is equal to A by B. Anything is okay, no problem. Where A and B are co-primes and B cannot be equal to 0. Now, other than root 2, remaining terms on that side, root 2 is equal to A by B minus 6. Do LCM, A minus 6B by B. We know that A and B are integers. Therefore, A minus 6B by B is a rational number. But root 2, what is root 2, children? But root 2 is a irrational. Root 2 is a irrational number. Therefore, my assumption is wrong. Therefore, our assumption is wrong. Finally, I say that 6 plus root 2 is a irrational number. 6 plus root 2 is a irrational number. So look here children, this is very easy. The technique here is you need to understand the given term carefully. Adjust such a way that only the surd should be on one side and remaining terms and other side. Then finally this becomes rational and this will be irrational. So according to that my assumption is wrong. Finally this is irrational. Okay. With this we need to end our session today. In our next session we are going to complete this chapter. Until that keep watching. Thank you all.